What does a unit mean? It's a measurement, okay? So units, so let's write this down on the back side of that paper. Units, okay, they measure things, okay? And we have a bunch of different kinds, okay? The one that you're probably most familiar with would be what? What do you guys think is the most, like, well, what's that a measure of?
Inches.
No? Length, okay? So length, okay? You have all these different kinds of measurements. Feet, inches, miles. And these are all U.S. measurements, meaning we don't use the same measurements as everybody else, which is kind of annoying, but is what it is. All right. You also have meters. You have kilometers, kilometers. All right. Centimeters, millimeters. Light years is a measure of distance, measure of length, okay? I'm sorry? It is, yeah, but it also, because light years are so big that you have to quantify that somehow. But yes, you're right. Light years. The time it would take light to travel a year. I forget how many miles it is, but it's in like, it's a lot. It's ridiculous. It's more than that. I forget what the number is. We can look it up later. All right, so the cool thing about length is that we can convert any length into any other length, okay? If you have, for example, let's say you have 3 feet. You can convert that into inches. You can convert that into miles, meters, kilometers, centimeters, millimeters, and even light years, okay? You can do whatever you need, all right? How many?
186, 282 miles per second.
186.
186,282 miles.
Say that again,
186,
282 miles per second. Wow. That's the speed of light. Okay. All right, so I can convert 3 feet into anything. Now what I want to do real quick is just convert 3 feet into inches. Okay? What would you guys do to convert 3 feet into inches? So 3 feet to inches. What would you do? Okay, so if I wanted to convert 3 feet to inches, what's the one thing that we need to know? Not divided by 12. Sit out in the hall. Right over here.
I'm done. I just need to
Just put it on my desk then. Okay, so 3 feet to inches. What I have to know is my conversion. Okay, if I have 1 foot equals how many inches? 12 inches, okay? So we need to know the unit conversion, all right? Now what I do is I do this, all right? And this is something that might be a little tricky for you, but if I take 3 feet, I want you to all write this down, over 1, this is a way to do unit conversion, okay? My goal is I want to have this in inches. So what I'm going to do is I'm going to multiply by this conversion rate. And I'm going to multiply it by 1 foot, 12 inches, over 1 foot. Okay? Now, knowing all of your unit rates and your conversion rates might not be something that you do or that you know. Typically what will happen is I can give you a table of them if you want so you can study. A lot of times they'll give it to you. All right, but there are some you need to know. Like this one is pretty standard. So converting feet to inches or inches to feet, or converting feet to miles, or miles to feet, whatever, okay? But what I want you to do is notice this. When I'm doing unit conversion, what measure, I have this, my original measurement, and what I want to do is keep that same measurement in the opposite denominator. Because what happens...
I started the question, and I already set it up like that.
Okay, so the question is, what happens if you take feet divided by feet? What do you get? They cancel out, they divide out. That concept of feet divided by feet divides out to 1. Okay? Kind of weird. But what that does is helps me remember whether I need to multiply this number by 12 or divide by 12, because those are your only options. What's up? So what I do is, when I do this, because remember, I'm converting feet to inches. Feet divided by feet divides out. And what you're left with are these numbers. You're left with 3 over 1 times 12 inches over 1. The feet have gone away. Therefore, the only measurement that we have left is inches. And this is how you do that. And every problem is different. You have to think about, what do you have? What are you trying to find? All that good stuff. Okay? But this is as simple as I can make it. Now, 3 times 12 is 36. So there are 36 inches in 3 feet. That's the idea. That's that conversion. Now, Google does this for you. All right? But this is something that, yes, you will have to do at some point in your life. Okay? And there are times where I sit there and I legitimately write out the math. Okay? Now, I don't memorize all of my unit conversions. There are some that I just know. Okay? Another one would be time. How do we measure time? Seconds is a measure of time. Minutes is a measure of time. Hours. Days. Weeks. And then, you can do months. Months is a measure, but they're not all exact. Years.
Decades.
Sure, decades, centuries, millennium.
Millennium.
Okay. But the idea, this is something that you can figure out, right? Okay, so my question is, how many seconds, and this is something I want you guys to try on your own, okay? Because you guys all know how to operate with time. That's a pretty standard one, okay? How many seconds are in 1 week? So, we're going to set this up. How many seconds are in 1 week? Okay? Now, I'm starting with seconds. Okay? And actually, I'm going to start with weeks because I want to find seconds. All right? So what I'm going to do is this. 1 week over 1. That's how I start this. You start with weeks and you want to end with seconds. Now, what I know is 1 week is 7 days. Notice how I put week over week because those will divide out. Those will cross out.
So then the next one you do, you'll have days on the bottom and then...
Exactly. So 1 day is, what do I got to convert to then? Hours? Yeah. Is 24 hours. Okay? The next thing I got to convert hours into minutes. So then 1 hour is 60 minutes. Okay? And then
60 seconds.
1 minute is 60 seconds. Okay? And that's the idea. Now look what happens. We did a bunch of conversions here. So what happens is that I have week divided by week, days divided by days, hours divided by hours, minutes divided by minutes, and you are left with seconds.
Wow.
Okay? That's how you do this. It's kind of tricky, but understand that all I'm just doing is these rates, okay? Then you just multiply the numbers. Now, since 1 is in your denominator in all of those, I don't even need to mess with that. So what I want to do is I've then got 7 times 24 times 60 times 60. So somebody do that in a calculator real quick and tell me what you get. Here's what you got. 604,800?
No, yeah, yeah.
Okay, that's the seconds in a week. All right? How many for you this is like all brand new information?
Start counting.
I mean, that many seconds in a week is.
But like doing it this way where you use these conversions and stuff like that. It might be. It's something that you learn when you're young, okay? When you're in elementary school. And we use them in classes, not that much, but a lot of times your units, being able to do this will be able to help you further down the road to answer some questions, okay? So there's questions, so length, time is a unit. We can talk about volume, area. Ooh, I like area. How would you measure, like if I had to paint the wall, what measurement would you need to know if you were painting the wall? Square footage. So, the question is, what does it mean to have square footage?
I feel like we're in one of those like questioning rooms in a
All right, so let's say hypothetically that this is, let's say it's 400, my room, the wall space, all the walls put together, the surface area of the walls, not the floors or the ceiling, is, let's say it's 500 square, now let's use 400, it's easier. Yep, let's just call it 400 square feet, feet squared. How do you get feet raised to the second power?
It's a split, putting a square, like by adding the perimeter of a square.
Not perimeter.
Or the area of the square will literally be what?
So think about it. Think about it. Yes, you're right. Okay, if I had a square by a square, let's say that this is 20 feet by...
more squares.
Hold on, listen. 20 feet by 20 feet. How do you get area? You multiply the length and the width, right? So area, in this case, is equal to 20 feet times 20 feet. Now remember, you can reorder things when you multiply, so you get 20 times 20 times feet times feet. 20 times 20 gives you 400. What's feet times feet? Feet squared. That's how you get that squared. Think about it like this. What's x times x?
X to the second.
X squared. Same thing here. That's how we write that. That's how we get that unit, okay? Is what it is. All right?
What's a hamburger and a hamburger?
2 hamburgers. Okay. So what I'm going to start off with is I'm trying to find length. How long is the tunnel? That's what I'm trying to find. And I'm trying to find this in feet. Okay? So here's what I know. We're starting off at 60 miles, not miles, but miles, per 1 hour. Okay? I'm going to convert that, the time. So I need to convert the time into seconds and distance into feet. Okay? And watch how I do that. So 60 miles per 1 hour. 1 hour is 60 minutes. Right, exactly. And then 1 minute is 60 seconds. Okay? So I've converted this into seconds. All right? Now, I also know that I've traveled for 8 seconds. So that number goes up here, 8 seconds over 1. Then I got to convert miles into feet. So I got to put miles on the bottom. So 1 mile is 5,280 feet. If you're doing this right, everything else should divide out. Okay, so here I go. Miles over mile. Hours, hours. Minutes, minutes. Seconds, seconds. I'm simply left with feet. Okay? Now, the other thing I can do 60 divided by 60. That's 1. So then my answer is simply just going to be 8 times 5,280 divided by 60. Okay, I'm just taking the numbers that I have left over, and then that's a measure of feet. So let's do that real quick. 8 times 5,280 equals, divide that by 60, boom, 704 feet. Now, here's the other thing. Let's look at all our answers.
Are we rounding here?
Yeah, approximately how long is the tunnel? That word, approximately, tips me off that it should be B. As in, boy, aren't we having fun. As long as you get the problem right, doesn't matter.
Yeah, because I ended up doing 520 divided by 60 seconds.
Multiplied it by 80.
And then do 80 times.
Yeah. And there's probably faster ways of doing it, but that's how I would set it up. Okay? And I'm used to doing that, but hopefully what you realize is this concept of unit conversion. This is a long one. This one took a while. All right, question 2. I'm going to give you 2 minutes. The answer you should get was B.
B?
Yeah. All right. This is one. Now, guys, I go to the store hopefully about once every 3 weeks. I go to Walmart in the morning and I buy a certain item. And that item is an 18-pack of Cliff Bars. Why do I buy the 18-pack?
Because it makes more sense when you're going for the long.
It's cheaper, right? I've got a big box, all right, that I use, and I just have them for snacks and whatever, okay? But what I do is I sit there and I go the cost per bar, cost per Cliff Bar. I take whatever cost it is, and I just divide that by the number of Cliff Bars, and that gives me the number. I want the smallest number out of that, okay? So in this, grocery store normally sells $3.50 per bottle. The grocery store is currently having a sale on lemonade, which advertises 6 bottles for $13.50. So how much cheaper is the lemonade on sale per bottle compared to the normal price? So what I do, cost per bottle.
350 times 6.
All right, cost per pound. All those different rates of change, that's what you want. And this is what we call the unit rate, hence the name unit. Okay, but I take the cost, 13.50, and divide it by 6 bottles. All right, and that's going to give you a cost of $2.25 per 1 bottle.
I did this out of order.
Okay, and that's how I figure that out. Then I take 3.5 minus 2.25, and that's going to give me a savings of $1.25 per bottle. Okay, this is savings. Yeah.
I just did 350 times 6,
Uh-huh.
which is 21, minus 1350 divided by 6 again, and that got me.
That'll do it.
Yeah.
Yeah. And again, if it makes sense to you and you're getting the right answer, doesn't matter. Okay? But being a smart consumer, you walk into the grocery store. How many of you have ever been in the grocery store and you whip out your calculator to look at stuff? None of you? Okay, good. Because that's what you should do. If you're sitting there buying something that isn't going to go bad, buy the big one because it's going to be more cost or less cost per unit. Moving on. So yes, this one and this one is this is something that you would probably do, hopefully, if you're looking for an apartment. Now, homeboy over here would not be looking at the highest cost per square foot. I would be looking for the lowest cost
Lowest cost per square.
per square foot. My reasoning is, so when I'm looking at that, all right, that's just me. I'm trying to minimize my cost. $500 versus $800, that's a big chunk of change. Okay, but if you're trying to look for the highest cost per square foot, so cost over feet squared is what I'm doing. And I'm doing all of them to see what I get. So if I do the first one, that's 500 over 400, which gives you, what is that, 1.25? The second one I'm doing 600 over 450, which gives you 1.3 repeating. Okay. The last, St. Clair, I'm doing 750 over 500, which gives you 150, $1.50, 1.5. The last one, 800 over 550, which gives you 1.45. Okay? Yeah.
When you're looking at this problem, like I know kind of intuitively, but how do you know which one to divide which by?
This. Cost per square foot.
So the cost
Cost goes first.
goes first.
Per is your division symbol, and then feet squared goes on the bottom. Good question. Yeah. Okay. And so I'm just looking for the largest number, which is the one from St. Clair Road. Answer is C. Okay.
So cost over square foot.
Okay. Yeah. And when you see that, like if you think like miles per hour, miles divided by hours. Yes. Yeah. If you go to the deli, cost per pound. Cost goes up top. Per pound.
That's awesome.
Yep. Okay. The answer is B, as in Barracuda Brothers. Okay. So, again, yes. Doc asked the question, do I have to know what this stuff means? No. You have to read the question. I read it 3 times. So I knew what it was asking me to do. Okay? So, the strength of a magnetic field is measured in Teslas. 1 Tesla, and that's this, the 1T, is equal to 1 Weber per square meter. Okay? Again, I don't know what any of this stuff means, but 1 Weber per square meter. So then what I did was, Divya is building a circuit for her physics class. Point P on one of her wires has a magnetic field strength of 6 times 10 to the 6th Webers per square megameter. Now, that is different than a square meter. All right? So, I wrote this. I wrote 6 times 10 to the 6th Webers, WB, over mega, so mm squared, just to distinguish between mm squared and what I had, times, okay, then it gave me this, 1 megameter, so 1 megameter, ooh, it might be wrong.
No,
I'll show you why I think I'm wrong. Over 10 to the 6th meters.
okay, but why do you have megameters squared underneath the 6 times 10?
Right.
Should I put
So what you would have then is, yeah, it's not B. Here's why. Because I've got Webers, megameters squared, right?
Yeah, but 1 Tesla is 1 Weber per millimeter squared.
But this is one megameter per meter.
Wait, hold on.
I need meters squared,
Are just,
right?
all right, so here's the deal. Here's what I did, right?
Okay.
So, Tesla, to 6 times 10 to the 6th,
Uh-huh.
Webers, right?
Right?
But since a megameter is equal to 10 to the 6 meters, that's just 1 times 10 to the 6 meters squared, effectively.
Uh-huh.
And so, of course, 6 times 10 to the 6 divided by 1 times 10 to the 6 is equal to 6. 6 times 10 to the 0.
Right. But what I'm saying is this. In order for me to have megameters squared, I got to multiply this by another 1
You don't
mega.
need megameters.
Why not? Because this part has to divide out.
Let's see. 1 Weber per square megameter. You already have megameters squared.
Right. I need megameters squared up here. Right?
Don't- Let's see.
Because listen, if I had
I don't
feet,
think you need to divide.
if I had feet squared over feet, that's just feet. I need feet squared over feet squared in order for these to divide out.
But do you even need to divide them?
Yeah. Because you're trying to get Webers per square square meter.
Where are you getting the feet from?
I've just made that up.
Okay, let's see. Per square.
So then I would have to multiply this by another 10 to the 6th meter. So then I would have 6 times 10 to the 6th Webers over 10 to the 12th meters squared. Then I divide the 10. Is it 6 times 10?
I can't see your screen.
Oh, gosh, sorry. We up?
Is it because you add the exponent?
Let's see. So let's
That's how you get 12. I think that's what you do.
following what's going on.
So when I'm doing this conversion, I've got megameters squared here. I have 1 megameter up here. In order for these to divide out, I need megameters squared.
Hold on. You do have, let's see. 1 megameter squared equals 10 to the 6 meters squared.
No, 10 to the 6 meters.
That's what I was saying.
The conversion you have is 1 megameter is equal to 10 to the 6 meters, not meters squared.
Well, then just square it.
I know, that's what I did. And that adding, like, I'm just multiplying it by itself.
Square it, does that turn the exponent just times 2 to 12?
Yeah.
So it would be 6 times 10 to the 6th over.
So 6 over 1 is 6. All of your numbers here are 6, but it's 10 to the 6th over 10 to the 12th. Remember, when you divide numbers with common bases, you subtract the exponents. I'm thinking 10 to the negative 6.
How can we subtract the exponent?
That's a question I don't have time to answer, but that's what you're supposed to do.
But then you keep the 6 times. Because there was
All I'm doing is just this division here, 10 to this.
you just divided the x.
Okay, so think about it. If I had x squared over x cubed, okay? Or let's do x cubed over x squared.
Oh, because there isn't another 6, so with the 10, it's just 10, 10.
Yeah, what I'm doing when I'm doing that is I'm doing x times x times x over x times x.
The 10s don't turn
X over x divides out. X over x divides out, you're left with x to the first power. So you'd have to take x to the 3 minus 2 power to get x to the 1.
so the 10s don't turn into a 1.
No, 10 stay the x didn't change,
Yeah,
okay? So the 10s don't change, the exponents do.
yeah.
Okay, that one's tricky. I would say it's after catching it, it's A, but
Skip with a double circle around it.
Is there by any chance an answer key just to make sure it
yeah, I can look. Yep. All right, let's take a look at question number 5. You should have gotten B. Okay. And here's what I'm looking for on this. Okay, table, I got to read it. Okay, table at the left, the total bone gives the total bone area in square centimeters. So here's bone area and bone mineral content in grams. Okay, so I'm just reading this going, okay, that's this list, that's that list. Of 4 healthy people, bone mineral density is the unit rate of grams of bone mineral content, so grams of bone mineral content per square centimeter of bone area. So your ratio is grams over centimeters squared. Which person has the highest, greatest bone mineral density? All I'm doing is taking those numbers and dividing them. And I just did them on the calculator. This was 1.16. This was 1.25. This one was 1.1. This one was 1.2. Person 2. Okay? That's how I did that.